Hello there, you beautiful people, and welcome to the logic section of the Python Bible. It's very rare in programming that there's just one route for a program to take. Usually there's quite a few possibilities, and you need to do something different in each of the cases. Now this is where logic comes in. Logic is basically the key to building any clever program or anything really cool, and it allows your program what to choose when. So in this lecture, I'm going to give you an overview of this section of the course and tell you what you should be expecting to learn. And by the end of the lecture, you'll know where we're going next, and you should be suitably convinced that this section of the course is really going to be a game changer in your ability to program in Python. So let's get into it. We're going to start off by taking a look at the Boolean data type in Python. Booleans are the basic of all logic and are the building blocks for every logic system we ever want to build. So that's a pretty good place to start. You'll then learn what Booleans are and how to create them. Once we know what the little building blocks are, we're going to move on to some operators that we can use to build logic. These are called conditional operators. These conditional operators will allow us to do things like check if two numbers are equal to each other or bigger than each other and things like that. You're going to learn what conditional operators are, how to use them, and what they're for. After that, we're going to learn about a critical piece of the Python programming language that it has been absolute agony to hide from you up until now, and not knowing about them has really limited what we can do, even though we still made some awesome things. And what I'm talking about are if-else statements. These are how we build logic structures in Python, and it basically lets us do one thing in a certain case, and if that case isn't appropriate, we can do something else. So that's going to be a critical lecture. Then you're going to learn about special keywords such as not, or, and well, and that will make your logic more readable, more controllable, and more powerful. We'll also learn about something called the in keyword. So this is a super useful keyword in Python that basically makes it possible to check whether something is in something else. So clearly, we have got a lot to learn about in this section, but I promise you, your Python programming skills will be absolutely supercharged by learning and understanding this section on logic. It's almost impossible to think of a program that doesn't use logic in the real world, so understanding this section is absolutely critical to being a top-notch Python programmer. So hopefully you're suitably excited and committed to learning all about logic in Python, and in the next lecture, we're going to kick off by learning about Booleans, which are logic's building blocks. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on Booleans and comparison operators. So what the heck is a Boolean? Well, Booleans are the building blocks of logic systems, and by learning about them, we pave the way for us to learn much more complicated things down the road. So in this lecture, you're going to learn what a Boolean is and how to create one, and you're also going to learn about comparison operators that allow us to compare two pieces of data and determine something logical about them. So for example, is x bigger than y, or is y equal to z, for example? Those would be some examples where you would use a comparison operator. So by the end of this lecture, you're going to know all about creating Booleans and using comparison operators to get your logic systems up and going. So let's get going. Okay, so what the heck is a Boolean? Well, Booleans are very simple data types and can basically only have two values, true and false. So let's go ahead and create a few Booleans. Let's say we had B is equal to true and C is equal to false. Pretty easy, right? So you can see here that idle has helped us out by turning the Booleans yellow so that we know that we've actually entered a valid value. Now, a common mistake is to spell Booleans all lowercase. So, for example, to have D is equal to true in lowercase like this. Now, you can see that that actually hasn't gone yellow. So if I try that, we're going to get an error, a name error saying true is not defined. So Python's actually looking for a variable called true, which doesn't exist, obviously. But if I did D is equal to true with a capital letter, that will work absolutely fine. Another common mistake that happens amongst beginners is that sometimes they type, let's say we had E, you type true within some quote marks like this. So yes, that is a text that says true, but if you look at the type of E, it's actually a string, whereas we want, like take B, we want bool, right? Type Boolean. This is just a string with the text true inside of it, whereas this is actually a completely different data type. It's a Boolean. This is just a string with the word true in it. So you need to understand that booleans are a data type in their own right, just like strings, integers, floats. Booleans are also their own data type, and you define them just by typing them, but just with a capital letter. Okay, so just make sure you've got that concept down, and with that we can move on. Now, we don't normally create booleans just by typing in their value. Normally we get them from doing some kind of logical comparison. So let me show you what I mean. Let me check if 2 is greater than 3. Now for that I need to make a logical comparison using the greater than comparison operator. So the way that I do that is 2 greater than 3. So this is a logical, this is a comparison operator that is comparing 2 and 3 to check if 2 is greater than 3, right? Now if I press enter, it's going to give me back a boolean that's false. So this is how we normally get booleans. We do some kind of comparison and it tells us whether that comparison is true or false. So let's see if we can get the value true. Well, for this we'd need to give a true a comparison that was actually true, right? So for that I could do 2 less than 3, because 2 is less than 3, therefore that's true. Okay, so if I just check the type of 2 less than 3, we see it comes back with a boolean, because Python is going to evaluate this expression and it's going to give back a boolean value. So you can see by doing these comparisons, this is actually how we create booleans normally, rather than just typing them out like we did at the beginning of the video. So we now have got some idea of how we can check whether a number is greater than another. We can check whether a number is less than another. How do we check if they are equal? Well, let's say I wanted to check if 2 was equal to 3, which of course it isn't, but just bear with me. So what we need for this is the equality operator. So now if I tried to just type 2 equals 3, it's going to give us an error, because we here have used the assignment operator, right? We've tried to assign 3 to 2, and it says you can't assign to a literal. You can't just make a number equal to another number. That doesn't make any sense. So to check for equality, we need to have the equality operator. And the equality operator is just 2 equal signs together. Okay, so this is an operator in its own right. So now we're checking, is 2 equal to 3? Is it equal to 3? And if we do that, it's going to tell us false, because that's not the case. Whereas if I did 3 equal, is 3 equal to 3 using the equality operator, then what that's going to give is true. So that worked absolutely fine there. So how can I check if two things are not equal to each other? Well, for that, I use the not equal to operator. So what's that look like? Let me just get some space here. Okay, so if the way that you do that is an exclamation mark and then an equals. This means not equal, not equal. So if I did 2 not equal 3, what do you think that's going to give me? If you guess true, then you'd be correct, okay? Because it is just checking, tell me, is 2 not equal to 3? It's going to say yes, right? Yes, it's not that. Yes, that's correct. So here is true. There's only really 2 other operators that that I need to show you, really, and then we've gone through all the comparison operators. So there is the greater than or equal to. So let's say if I did 4 is greater than or equal to 3. What do you think that's going to give? If you guess true again, then you'd be correct, because 4 is bigger than 3. So this makes sense. Any number that's greater than or equal to 3 will make sense. So if I did 3 greater than or equal to 3, what will that do? Again, that's going to give true, right? But if I had 2, if I did 2 is greater than or equal to 3, that's going to give false. Now, of course, as you may have guessed, you've also got the less than or equal to. So if I had 4 less than or equal to 3, what's that going to give? It's going to give false, right? But 2 less than or equal to 3 is going to give true, and same as 3. 3 less than or equal to 3 is going to give true. So there we have it. I mean, that's pretty much all there is to know about Booleans and comparison operators. It's more how we use them that actually makes the difference here. We now know that Booleans only have 2 values. They are true and false. And the way that you tend to generate them is by comparing or making a logical comparison between several pieces of data. So there are a few logical comparison operators. There is the greater than, there is the less than, there is the equality operator. Remember this one, it has to be two equal signs and not one. If you just have one, you're trying to assign the value to what's on the left, which is not what we want. We want to check whether they're equal, so we need the equality operator. You've got the not equal to. The exclamation mark means not, so you've got not equal. You've got greater than or equal to, and you have less than or equal to. So there are 6 of them. And most of them are quite intuitive, right? The only ones that really might trip you up are these 2 here. So yeah, that's all you need to know there. So the thing that really makes these things come to life is what we've got in the next video, and that is the if statement, which we use to build up logical constructs. I'm not going to spoil it, but it basically uses these comparisons to tell the computer which code to execute when. So I have a quick quiz prepared for you right now, just to check your understanding of comparison operators. And after that, we're going to jump right in to learn all about Python's if statement. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on the if statement. This lecture holds the magic key to supercharging your programming ability, so be sure to soak up every last drop of knowledge from this lecture that you can. It's going to be so worth it, I promise you. So in this lecture, we're going to go over the if statement. You're going to learn what an if statement is, how it works, and how to use one to control your code. You're also going to learn about the else and else if keyword that will basically make you a logical genius in no time. So by the end of this section, you're going to know how to create logic in Python, and you'll be well on your way to creating smarter and more intelligent programs. So let's get into it. Okay, so first of all, what the heck is an if statement? Well, an if statement allows us to execute a certain piece of code only if a condition is true. Now this gives us fine-grained control over what pieces of our code are executed when, and allows our programs to be rather intelligent. Let's see what one looks like, right? So first of all, we type the if keyword, which you can see is all lowercase and it's gone yellow. You then type some condition, like what I was showing you before with the comparison operators, and then a colon. And then everything inside of this if statement will only be executed if this condition is true. So let me show you what I mean by this. I'm going to go ahead and create another file called if.py. So let me save this, desktop, Python Bible, if.py. So let me maximize this and we're good. So what I'm going to do is on the very first line, I'm going to type the word if, then the Boolean true, then my colon, and I'm going to press enter. Now you're going to see here that Python has immediately indented my cursor. And with when we use logic and all this kind of stuff where things go inside other things, called nesting, if you zoom out of the code, it makes the code look like it goes in and out and like moves around, and it kind of looks like a snake. Okay, so that's my personal reason why I like to think Python was called Python, but I think it was named after Monty Python, the old British comedy show. So anyway, that's an aside. Inside here, I'm going to print it worked. Okay, now I'm going to save and run this, and we're going to see that it prints out it worked. So let's break it down, see what happened. Let me open back up that code. I said that the way that you make your if statement, you have if, then a condition, then a colon, then something inside. Right? So let's just say the code inside. Well, the way that this worked is our condition, say if we did 3 is greater than 2, right? At the end of the day, that condition is either going to give back one of 2 values. It's going to give back true, or it's going to give back false, right? Now, whatever condition is here, it's either going to give back true or false. If that condition gives back true, then the code inside the if statement will run. So by writing true here, it's basically just, it's got what the if statement wants. If I wrote false in there, the code won't run. So if I do this now, we see nothing happened, right? So only if this condition, whatever it is, comes back to give true, will the code work. So let's say I wanted to check whether a number was bigger than another one. Okay, so let's go back into our script. Where's the script? Right. So what I'm going to do is I'm going to create a variable called num1, and I'm going to set that equal to 100. I'm also going to create another variable called num2 and set that equal to 50. Now I want to check if num1 is bigger than num2. And if it is, I want to print num1 is bigger to the screen. So for that, I need to use an if statement. So let's just delete this and start from scratch. An if statement always starts with the if keyword, just like that. You can tell you've done it right because it's gone yellow. Then I need a condition. So my condition is going to be num1 is greater than num2. Now this condition, as we saw before, it's going to give back true or false, just like we saw in the last video. You then put a colon, hit enter, and the code's going to automatically indent. And I'm going to, inside this code, if that condition is true, I want to print num1 is bigger than num2. So if I save that and I run it, we're going to see that num1 is bigger than num2 gets printed to the screen. But if I change num2 to be 150, let's say, so now num2 is bigger, if I run that, we see nothing happens. Because what Python did is it checked, is num1 bigger than num2? Is 100 greater than 150? It came back with false. Therefore, the if statement won't run because the if statement only runs when its condition is true. So let me just set these numbers back to what they were to begin with. Okay, now we've got a condition. If this condition is true, this code will run. So how can we get something else to run if the condition is false? Well, for that, we need to use the else keyword. Okay, so let's say I would do else here, and let's say print num2 is bigger than num1. So if this condition isn't true, it will run this code. So let me show you. For now, num1 is bigger than num2, right? Because 100 is bigger than 50. So if we run it, it's going to say num1 is bigger than num2. Brilliant. But if I go back and I change it so that num2 is bigger, let's say make it 500 this time, now what's going to happen is it's going to say num2 is bigger than num1. Amazing, right? So now our code is being able to think and respond depending on the state of our variables. But what happens if I make these two equal to one another? It says num2 is bigger than num1, which isn't true, right? Now let me just break down why that happened. It first checked if num1 is bigger than num2. Okay, that's false because they are equal, right? 100 isn't bigger than 100. They're equal. And we told it in every other case, say num2 is bigger than num1, right? So when they're equal, because this is false, it's still going to print this, and that's not what we want. What we want to do is first check if num1 is bigger, and if it's not, check if num2 is bigger, and if it's not, they must be equal. So for that, we're going to use the else if or elif keyword. So let me show you what I mean. If num1 is bigger than num2, do this. Else, if, so elif num2 is bigger than num1, then print this. Print num2 is bigger than num1. Else, print num2 or num1. Actually, no. Both numbers are equal. So what happens here? If num1 is bigger than num2, print num1 is bigger than num2. Else, if num2 is bigger than num1, print num2 is bigger than num1. In every other case than these two, if both of these are false, just say both numbers are equal, which is what must happen. So if I run that, it's going to say both numbers are equal. Now, how cool is that? So if I go back in here and I change this to be 105, so num1 is bigger, it's going to say num1 is bigger than num2. And if I go in here and I change this to be 500, it's going to say num2 is bigger than num1. And if I change them both to be 500, it's going to say that both numbers are equal. Now tell me that isn't amazing. Epic. You've made a program that can think. Well done. So we've covered quite a lot in this lecture. So let's just have a quick recap to make sure that you've got it all. You first learned that an if statement is created using the word if in lowercase, followed by some kind of logical condition and a colon, which is the two dots on top of each other. When you press enter, the code's going to automatically indent to show you what's inside, what the code is that would run if this condition is true. That code will only run if the condition is true, and it won't if that condition is false. It's as simple as that. You then learned how to make something else happen if the first condition is false. So you'd have some condition here, you'd have some code, and then if that condition is false, you would run the second code, right? So it would check this condition. If that condition is true, it will run this. But if it's not, it will run this. If this condition is true, this code won't run. Okay, so that's where you use the else statement. Now, sometimes you want to check one condition, and if that's false, you want to check another condition. For that, you would use the else if. So you'd have condition 2, code 2, and you might have multiple of these as well. So you could have like condition 3, code 3, and otherwise you'd have code 4. So if the first condition is true, this code will run. If that is false and this is true, this will run. If that is false and that is false and this is true, then this will work. And if all three of these are false, then this one will work. Okay, so you can build up rather complicated logical systems using just these rather simple building blocks. So I'm sure you can begin to grasp just how powerful this can be in your programs, right? Especially when you can have variables in your conditions, and these variables can be updated from other parts of the program, and they can be automatically updating themselves and stuff. It's really, really powerful stuff. So there's still quite a lot of cool stuff to be coming up. Sometimes we want to combine multiple conditions together. So maybe you want to check whether two things are true, or if one thing is true or another thing is true in one condition. And being able to combine conditions together to make one condition is where we need logical operators, which are what are up next. So up next, I do have a coding challenge for you to check that you've understood this lecture. And after that, I'll see you in the next video to learn about logical operators to make our conditions a lot more powerful. Hello there, you beautiful people. Now, it's very common when we're working with logic to want to combine multiple conditions into one. And this is where logical operators come in. In this lecture, you're going to learn about the not, or, and logical operators. So by the end of this lecture, you're going to know what these powerful operators are and how and when to use them. This is useful basically everywhere in logic. In fact, without knowing about logical operators, you won't be able to do much real logic at all. So with that, let's get into it. So the first question is, what the heck are logical operators? Well, first of all, logical operators are different to comparison operators. Comparison operators like greater than, less than, equal to, and all those things we covered before, are used to compare pieces of information to make conditions. Logical operators, on the other hand, combine and modify the conditions to make bigger conditions. So comparison operators make conditions, logical operators combine the conditions together. So I'm going to start off by showing you the not logical operator. This is the simplest logical operator and basically gives you the opposite of what the condition would have been otherwise. So for example, not, you can see the way that it's gone yellow, not true gives false, not false gives true. So like for example, if I had not 2 less than 3, okay, 2 less than 3, what's that? That's true, right? So not true, false. What about not 3 greater than 1? Actually, that's going to be false again. Now, what about not 4 equal to 3? That's going to give true, because 4 equal to 3, That's true, not true, false. Now we can use these logical operators in if statements. So for example, if I had x and I set that equal to 10, and I had y and I set that equal to 20. Now if I wrote the if statement, if not x less than y, actually no, if not y less than x, then print it worked. And we're going to see it says it worked. And the reason why, well, is y less than x? Is 20 less than 10? No, right? So that would come back as false. What's not false? True. So this whole condition here became true, and therefore this code worked. So you can see the way that the logical operator has managed to modify the condition in a rather simple way. Now we can actually represent this behavior in what's called a truth table. So down here I have a diagram of a NOT gate, or like a NOT operation. This is how they're drawn in circuit diagrams and things like that. So we have an input called A and an output. And instead of writing true and false all the time, but in these truth tables, people write 0 to be false and 1 to be true. And what you can see is that if A, or the input, is false, the output is true. And likewise, if you have the input is true, then not A, or the output, is going to be false. So basically, the NOT gate just gives you the opposite of the input, right? So with that out of the way, let's have a look at the AND operator. Now this is the truth table for the AND operator. You can see that unlike the NOT, which only had one input, AND has two, right? So you've got A and you've got B, and you get one output. So the key thing about the AND is that it only gives you true if both of the inputs are true. So if A, another way of saying that is if A and B are true, then the output will be true. That's why it's called the AND gate. So if you look here, if A is false and B is false, you're going to get false. If either one of them are true, you still get false. But when A and B are true, you get true. So that's the AND gate. Let me show you an example of this in our Python code. So as an example, let's say we have C is equal to 10 and we have D which is equal to 5. Now if we have an if statement like this, if C is greater than 10 and D is greater than 1, print it worked. Now, why didn't that work? Okay, the reason why it didn't work is because, well, let's break it down. Is C greater than 10? It's not, right? Because C is 10. Okay, so is 10 greater than 10? That's false. So we've got false here. Okay, I'm just going to write this. False. We then have AND. And now what have we got here? We've got D greater than 1. Is 5 greater than 1? Yes, it is, right? So true. Now remember, when you have, this is basically input A, and this is input B. Only if both of those are true will you get true. Okay, so at the minute, we've got false and true, which is false overall. So this overall is false, which means the if statement won't run. Now, if I change it so that if C is greater than or equal to 10, okay, now is 10 greater than or equal to 10? Yes, it is. Okay, so we're going to get true for that. And is 5 greater than 1? Yes, it is. So we're going to get true and true, which is overall going to be equal to true. So this whole thing is going to be equal to true, which means if true, that means the whole code inside is going to run, doesn't it? So if I click that, there we go. So now because both of the conditions are true, our code will work. So now I want to show you something that might blow your mind a little bit. Okay, we can combine not and together, okay, to make a a NAND, basically, a not AND. So let me show you what that is. At the minute, we've got this working, don't we? So what I want to show you is if I change C, let me just take this and just make it just like it was before, right? So this won't work, okay? Because we have false and true, okay? That all comes to false, right? You're with me so far. This is exactly what we had at the top here. So what I'm going to do is I'm going to type if not, and then put in brackets like that, okay? Print it worked. So let's have a little breakdown of what this is going to do. Okay, now you remember from the BODMAS and math stuff that we did before, whatever's inside of brackets is going to be executed first. So let's start there. Is C greater than 10? Is 10 greater than 10? That's false, right? So that's going to be false. Is D greater than 1? So is 5 greater than 1? Yes, it is. So that's true. What's false and true? That's false, right? So this whole bracket here is going to be false. So this whole bracket here is going to be false. But what's not false? True, right? So now overall, just by putting the not there, it works. Even though we had the same AND condition here as we did here, by taking the not of that, we managed to get the code to work, which is very useful. So the point that I'm trying to get across to you there is the way that you can use brackets to allow operations or logical operations to happen on each other, right? So we used a bracket here to say, take the not of whatever this bracket is, right? If I didn't have the brackets, what would happen is it would take the not of this and this. So that's super confusing, right? But it's the difference between taking the not of the whole thing and taking the not of just this one on the left. By putting the brackets, we say take the not of the whole thing. Without the brackets, we just take the not of what's on the left. So I know it's a bit confusing, but with practice it makes sense. So in the interest of time, I'm going to cut this video short because we've just got one more logical operator to come on to, which is the OR operator. So I'll see you in the next video to talk all about the OR operator. Hello there, you beautiful people. So the final logical keyword, the final logical operator that we have is the OR operator. So what the OR operator does is it gives us true if input A or input B are true. So as we can see from the truth table, it gives us true if either one of A or B or both of them are true. So if B is true, you're going to get true. If A is true, you're going to get true. If A and B are both true, you're going to get true. But if they're both false, then you're going to get false. So basically, OR is a very forgiving type of logic. So you use it if you just want to check whether any of these conditions are true. So let me show you an example. Okay, so let's create a variable called C, and let's set that equal to 5, and D is going to be -1. So let's have our logic, our if statement, say if C is greater than 1, or in lowercase, sorry, or D is greater than 1, then print it worked. And that worked, right? So let's see why. So is 5, well, first thing it's going to check is C greater than 1? C is 5, so is 5 greater than 1? It is, right? So we're going to get true. Then you've got OR in the middle. Now, is D greater than 1? Is -1 bigger than 1? It's not, right? So that's going to be false. But because one of the inputs to OR is true, the overall thing gives us true. So that means the condition here is true. If I had C, let's say if I had D is equal to 5, right? And had if C greater than 1 or D greater than 1, print it worked. Okay, so C is 5, right? Is 5 bigger than 1? Yes, it is. Okay, so we get true for that. Is 5 now, because D is 5, is 5 bigger than 1? Yes, it is. So now both of these conditions are true. And that also gives us true. The only way that this will fail is if both are false. So if I said if C is greater than 100 or D is greater than 100, print it worked. I can't spell. It worked. That's not going to work, right? Because C is 5. 5 isn't greater than 100, so you get false. And D is 5. 5 isn't greater than 100. So you get false. False or false? False. Okay, so that's how the OR operation works. Now you can combine this with the NOT, just like we did with the AND. So take, for example, if I did this, we know that that doesn't work, right? That comes false. But if I did a NOT here and put a bracket around all of this, now I'm saying take the NOT of whatever this gives. We know this gives false, so what's not false? It's going to be true, right? And now it's going to work. So that's how you can combine together NOT and OR to create a NOR, basically, which just gives you the opposite of what the OR would give. So combining together all these operations is how you make really, really powerful operations of your own. So let me show you a rather complicated example to show you what I mean about how you can combine these operators. Okay, now this is rather heavy, so bear with me, but it's going to show the point. I'm just going to give us some space here, and I'm going to create C equal to 6 and D is 2. Okay, C is 6 and D is 2. And I'm going to write this condition. If C is greater than 5 and D greater than 5, or C greater than 1 and D greater than 1, print it worked. Now I'm not going to press enter. I'm just going to walk you through what answer this is going to give. Okay, so let's start on the left, because that's how these things work, right? Let's start on the left here. C is 6, so is 6 greater than 5? That's true, right? That's going to be correct. Okay, so we've got true here. Is D greater than 5? No, it's not, right? Because D is 2, and 2 is not greater than 5. So we've got true and false. This whole bracket here is going to be false. Okay, so we've got false on the left side of an OR. Now on the right side here, we've got C is equal to 6. So is 6 greater than 1? Yes, it is. So that's going to be true. Now we've got D greater than 1. Is 2 greater than 1? Yes, it is. So this is true and this is true, which means this whole bracket is true. Okay, so we've got this whole bracket being false, this whole bracket being true. What's false or true? That's going to be true, right? So if I press enter, it worked. Okay, so this whole bracket became false, as I showed you. This whole bracket became true. False or true gave true. The whole condition was true, which means this code was ran. So I know that was a bit hardcore, but that's how these conditions are combined together to make more powerful conditions. What we'd be checking is if they're both bigger than 5 or they're both bigger than 1, run this code. Okay, so in plain English. So that's a very powerful ability to be able to combine all of these things together. And actually, to be honest, you could go another level if you really wanted, just for example purposes. We know that this works, right? That works. But I could make it not work by putting a bracket around all of this. I could make it not work, putting a bracket around all of it and typing not. Okay, and now that won't work because it was true. Not true is false. So now this whole condition is false and it didn't work. So you can combine and mix and match these operators as much as you like, which is a massively powerful ability. Phew, well, after all that logic, my brain is starting to hurt. So let's have a quick recap to make sure that we've got it all. So in the last lecture, we started looking at the not condition. The not condition basically reverses what you'd get otherwise. So not true is false and not false is true. Simple. After that, we had a look at the AND condition. The AND condition only gives you true if both inputs are true. So if A and B are true. Then we had a look at the OR condition. The OR condition gives you true if A or B are true. So if either of the inputs are true, OR is going to give you true. It also gives you true if both of them are. So OR is like a more flexible AND. Now we can combine these NOR and OR. Oh my god, that's so confusing. But you can combine these three conditions to make more powerful conditions, like the one that we saw here. Now obviously this is a lot to take in, and the best way to do it is by practice and try and get in real life in your code. Trust me, when you know what you're looking for and what you're trying to program, all of this is really easy to do. So to help with that, and to help give you some practice, I've got a multiple choice quiz up next to help you solidify the concepts, and then after that we're going to have a section review and move on to the data structures section of the course, which lend themselves very well to being worked with logic. So we should have some quite good practice there. So up next you have the multiple choice quiz, which I wish you the best of luck with, and I'll see you in the section review. Hello there, you beautiful people, and welcome to this section review of the logic section of the course. Now, I'm sure you'll agree that what we've gone over has probably just been a game changer in your ability to program in Python. So let's take a step back and have a look at what we learned. So first of all, we started looking at what booleans were, and we learned that they're a data type in their own right, and they have one of two values. They can either be true or false. And the way that we tend to get booleans is by using what are called comparison operators. So comparison operators compare several pieces of data, and if the comparison about them is true, you're going to get a true boolean, and if the comparison about them is false, you're going to get a false boolean. So comparison operators are like greater than, less than, greater than or equal to, less than or equal to, and not equal to. Now, the one thing that you've got to bear in mind is when you check whether two numbers are equal, make sure to use the equality operator, which is two equals symbols, rather than the normal one equals symbol, which you use as the assignment operator. Okay, so after that, we had a look at if statements. Now, if statements are the way that you can tell Python to run certain pieces of code or not, depending upon the case. So if statements basically each have a condition, and if that condition is true, or using some comparison operator, then the code will run. If it's not, then it won't run. And you learnt about how to use the else if to check for another condition, or how to use else as a catch-all for every other possible opportunity. Then we moved on to how to combine together multiple different conditions to make one big condition by using logical operators. In here we learnt about the not condition, which basically reverses what the condition would be otherwise. So not true would end up being false, and not false would end up being true. You also learned about the AND condition, which only works if two inputs to the AND are both true. And you learned about the OR condition, where if any of the inputs to the OR condition are true, the output will finally be true. So as a quick summary, if you understood all of that and you're feeling comfortable with all of that, then brilliant. You're definitely ready to move on to the next section of the course, which is about data structures. So data structures are pretty much a way in Python to combine together pieces of information into one nice, easy to use place. So I won't spoil it for now, but I'll see you in the next section where we're going to be learning all about data structures. So I'll see you in the next video.